Welcome to this NPTEL MOOC course on Phonetics and Phonology, a broad overview. So, we are on the unit that is the last unit of tone and intonation. Today, we will look at what do we mean by prosody and its linkage with intonation. So, we'll start with prosody and what it means. In modern generative phonology, the references given here, which we will put at the end of the course, refers to non-segmental aspects of abstract linguistic structures. So, phonologists give primacy to abstract descriptions, as we already know from our introduction to phonology, and in prosody also phonologists try to look at the abstract representations and the abstract descriptions of even non-segmental phenomena. So, as you understand, in prosody we talk about non-segmental phenomena, and they also look for empirical evidence in the realm of speech. So, while they do they look for abstract descriptions or abstract generalizations or abstract analysis, they also look for empirical evidence in the realm of speech. And while we talk about prosody, we need to know about human speech. What are the sequence of phonemes, syllables, or words? So, what happens in the level of pitch? Pitch moves up and down in a non-random way. So, it will be phonologists and linguists have for a long time known that when we make use of pitch in speech, we do not use it randomly. So, there's a reason why it rises or it falls, or there's a break, or there's a pause, or something is lengthened, or all those things that we normally will not study in the segmental part of phonology and phonetics, we'll study in prosody. So, segments or syllables may be shortened or lengthened, and some syllables or words sound more prominent than others, and the stream of words is subdivided into phrases. So, we'll come to this, we'll talk about this more when we look at the phonology of intonation and what are phrases. Do we actually speak in such a way that we break the utterances into parts? Okay. So, very often the word suprasegmental is used to describe prosody, when two or more segments occur simultaneously with those segments. So, these are the properties which are often thought to be suprasegmental, that is above the level of the segment, that is fundamental frequency, duration, amplitude, and also stress, which we studied, which we looked at in the previous lecture, stress and length of a vowel, word length, and various aspects related to length in terms of its relation, in terms of its position in a word, and also tone and intonation in general. So, the term suprasegmental is often used as a partial meaning of prosody for features in relation to segmental units, that is phonemes, and implying that the features concerned are above or larger than phonemes. And what are those features? These are the features, that is fundamental frequency, duration, amplitude, that these are above, or they constitute larger units rather than the segments that we have studied so far. And phonemic tones and phonemic pitch accents and prosodic forms are not in great need of phoneme segments as a reference point. So, phoneme segments, they do not just look for one phoneme segment, that is tones and pitch accents. They're not actually dependent on particular phoneme segments as reference points, and that they are above, and that's why the name suprasegmental. So, it's sometimes used as one of the meanings of prosody, but as we know that utterances with single phonemes also have prosodic properties. So, how do we know that? Because even they will not be related to more than one segment. They can be just related to, can be expressed with just one segment, like oh, so those are just one segments and those express something in the prosody. So there would be surprise or question, etc. They do not need more than one segment. So in a sense, then prosody captures this. The idea of prosody captures this, that it is not just more than one segment, that this is, we are talking about a level of organization which is not really dependent on the segments. So prosody is a hierarchical organization of speech. When we talk about phonology, it's inherent in the understanding of in phonology is that prosody is a hierarchical organization of speech, and prosody has both phonetic and phonological aspects. The phonological aspect is the hierarchical organization of segments into constituents with a pattern of relative prominences within these constituents. So phonological aspect is the hierarchical, this aspect that is the hierarchical aspect, that there are levels of organization of prosody and that there is relative prominence. So which means one is more prominent than the other in a sequence, and those aspects are extremely important when we are looking at the phonology of prosody. And further, that the chunking aspect that we talked about before, that constituents include intonational phrases, prosodic phrases, phonological phrase, accentual phrase, etc. We will talk about these in greater detail in the other lecture on the intonational phonology. So this, as you see here, we can see the hierarchical organization, that this is the largest level, which is the utterance, that is the sentence, and then we organize it into further units like the intonational phrases, and there can be two intonational phrases in an utterance, there can be smaller phrases, and then there could be the word level, and then the word can be further divided into other parts like the syllables, like feet, etc., mora, etc. So phrase level prominences include nuclear pitch accent and pre-nuclear pitch accents. We will talk about why some analyses have nuclear pitch accents and pre-nuclear pitch accents in the lecture where we talk about intonational phonology. And however, in every analysis of intonation, word level prominence, that is stress versus unstressed syllables, is very important. And when we talk about the phonetics of prosody, set of acoustic parameters that provide evidence for prosodic organization, that is stress, length, all these things are important in the phonetics. So the IPO model is one such model which models prosody. So we're going to talk about the IPO model in this lecture, and we will talk about other models in the other lectures. So in the IPO model, the ensemble of pitch variations in the course of an utterance. So this is the definition of intonation. So pitch variations in the course of an utterance, that is, it is when we talk about the course of an utterance, note that we are talking about the continuous changes in an utterance. That is what you are talking about here. So that's a difference between different approaches to prosody, that some talk about the continuous changes, some talk about it in categorical way, that these are different pitch accents, and some are talking about the relative differences, continuous changes in the utterance. So keep that in mind. And also the IPO model paid attention to the perceived speech melodies, and thereby paying less attention to pitch variations that are related to the segmental structure of speech. And the linguistic function of pitch. Fundamental frequency is the rate at which the vocal folds vibrate, and we know this from our course from our classes, from lectures on acoustic phonetics. So fundamental frequency is the rate at which the vocal folds vibrate, and smaller vocal folds vibrate faster and leads to increased airflow and increase in pitch. And an individual can raise fundamental frequency by pulling the vocal folds tighter so they vibrate faster. And the rate of vibration of the vocal folds, F0, is measured in hertz, and that is, as we know from the classes in acoustic phonetics, that 1 hertz is 1 cycle per second. And there's a difference between generally, but this is not an absolute difference. So generally for males it could be around 80 to 200 hertz, and for females around 180 and 400 hertz, the range, the pitch range along which we will find the pitch differences, the pitch changes. Within this range, each speaker has to a large extent active control over the fundamental frequency. And however, many details of the actual course of pitch in speech are not actively controlled by the speaker. And fundamental frequency conveys paralinguistic information, our emotions, happiness, sadness, etc., the speaker's sex and age and speaker's emotional state. The fundamental frequency may be affected by various linguistic factors. Fundamental frequency can differ by language. Average Japanese fundamental frequency is higher than that of English. So etc. So this fundamental frequency is dependent on a lot of factors. So the variations will be dependent on those factors. So fundamental frequency can vary according to the segment also, and these are not strictly suprasegmental properties. High vowels have high fundamental frequency, and consonants may have a particular fundamental frequency depending on whether they are voiceless or voiced. Voiceless consonants cause local pitch raising. Consonants may affect fundamental frequency of following vowels. In Yoruba, g rises into a vowel, but k falls into a vowel. So there's either a rise or a fall, depends on whether they are voiced or voiceless. So now what you see here is the measured course of pitch in a Dutch sentence with only two voluntary pitch movements and accentuating rise on the syllable klein. So note this is and then accentuating fall on dent. So all the others are, what we mean to say that all these changes here are involuntary changes. Only these two are controlled by the speaker. And why is this so? And what is there a perceptual bearing of these kind of changes is what we are going to talk about in the rest of the lecture. So all these involuntary rise and falls that you see here in the pitch, that is falling, again rising, and rising here, falling, we are saying that all these rise and falls are involuntary, and these are called consonantal perturbations. So consonantal perturbations are short, sharp, sudden movements in the fundamental frequency, and pitch accent contours are much slower and either fairly smoothly rounded as in the second sentence or dwarfed by the sharp sudden movements of consonantal perturbations. So what we are saying is that as you can see, this is slow, smooth rise here, unlike this sharp sudden rise and fall. So that's the difference between pitch accents or the ones the pitch changes controlled by the speaker and the pitch changes which are not controlled by the speaker. These are sharp, sudden rise and falls. So and the sharp, sudden rise and falls are what we call consonantal perturbations. And the obstruent consonants, plosives or stops, fricatives and affricates add noise frequencies because of friction caused by air forced out of the vocal tract. We know fricatives are noisy sounds. We've discussed that in the acoustic phonetics lecture. And Different consonantal perturbations can be illustrated by producing and listening to the voiceless fricatives f, sh, s. We have seen in the acoustic phonetics lecture how these cause different noises at different frequencies. So, this is what we call the consonantal perturbations, and other changes in the pitch contour is called microprosody. So, consonants affect the vibration of the vocal folds by narrowing the vocal tract, inhibiting the flow of air in the mouth, changing the air pressure, and frequency at the start of the consonant becomes lower for voiceless stops, but the effect with other obstruents generally not so obvious. So, voiceless stops can affect the vowels, the pitch, because it narrows the vocal tract, inhibiting the flow of air. It changes the air pressure. But the obvious effect with other obstruents generally not so obvious, as we just said, and the very short patterns resulting from the modification of fundamental frequency by consonants are known as consonantal perturbations or microprosody. So, these segmental effects are called microprosody, and even with a good pitch track, it can be difficult to decide what is linguistically significant. Segments cause perturbations in the fundamental frequency. In the fundamental frequency contour, edge effects, transitions from voiceless to voice can often be accompanied by disruptions of regular periodicity. So human perception though bridges the gap between this threshold. So, it is only when the pitch is very drastic that the gap is perceived. But interruptions of the sound of speech during intervals of voiceless consonants are perceived to be longer when they exceed roughly 200 milliseconds. So, the human perception threshold compensates for these gaps, and silent gaps longer than this effectively prohibit perceptual integration of preceding and following sounds. So, 200 milliseconds is a long time. So, something below that is not even perceived by the human perception mechanism. So, that is why these microprosodic effects are not relevant when we are talking about the perception of general prosody by in human speech. During most vowel sounds in normal speech with normal loudness, pitch can be determined with an accuracy of a few percentage. So, normal loudness level, pitch is determined with accuracy, but with if there is higher, if it's louder, then that may interfere with perception. For the study of intonation, pitch distances are more relevant than absolute pitch. So, the distance from one height to another is more relevant. And for a male and female speaker, we have different pitch levels. It is often useful to measure pitch in semitones because that gives you an idea about the perception. The semitone scale, a log scale derived from the Hertz scale, the distance d in semitones between two frequencies f and 1, there is a formula for the distance, and you can get the log value after dividing the f1 from the f2. So, this is a formula for the calculation of the semitone, the semitone scale. So, we will have to find the value, logarithmic values after doing after multiplying the f1 by f2. So, this is the calculation, and we will not talk about semitone scale anymore, but if you are interested in perceptual studies of pitch, then the semitone scale can be useful. So, now we come to the stylized approximation of pitch fluctuations in natural speech. So, why do we resort to, or why do we have stylized approximation of pitch fluctuations? Because as we just talked about, that the actual what you see in the fundamental frequency, the short, sharp rises and falls are actually not even perceived by human speakers. So that is why we have stylized approximation, which takes away these small changes which are not perceived by speakers. And that brings us to the perceptual model of pitch, and this is called the close copy stylization of pitch in speech utterances applied by the Piper to British English. And so we see the natural measured F0 curve of an English utterance. We'll see that close very soon. A close copy stylization is defined as a synthetic speech melody meeting two criteria. It should be perceptually indistinguishable from the original. It should contain the smallest possible number of straight line segments. So this is why it is called the perceptual model, because it should be the close copy stylization, or the after removal of the microprosodic effects, it should be perceptually similar to what was the original with the microprosodic effects, and it should contain the smallest number of straight line segments, and which means that if you have too many straight line segments, it will then also include the consonantal perturbations. So the graphical representation, the close copy stylization, continues through the voiceless portions of the utterance. So when we have voiceless portions, we don't have the F0 track at those points, but close copy stylization will ignore those and also draw a straight line through the voiceless portions. And the Piper, a formal experiment using 64 native speakers of British English, and the pitch curves of natural utterances can be simplified to sequences of straight line segments in a time log F0 domain without too many noticeable differences. So this is what we were talking about a while ago. This is the close copy stylization, unlike what you had seen before with the consonantal perturbations. As you can see, this utterance has the smallest number of pitch rise and falls. You can basically just see two here. And what are those two? Those are the parts which are emphasized by the speaker. And as we had in the beginning of the lecture, we had talked about how stress and prominence, relative prominence, is important in understanding pitch. You can see that here, that these are the two most important points in that utterance. So these measured course of pitch in a British English utterance, together with so-called close copy stylization containing the smallest number of straight line segments, with which perceptual equality between the original and close copy can be achieved. What's the sentence? The sentence says Alan's in Cambridge studying botany. So here Cambridge and botany are the two syllables which are most prominent, and the close copy stylization shows exactly that. The three equidistant lines in figure 3 to be called basic pitch levels: top line, midline and baseline. So and we can see that we have the baseline for the description, and then what we have, the prominence moves from the baseline, and it shows that those are the parts which have been which are the most sort of significant events in this utterance. So for the description of Dutch intonation, for example, it appears that two such basic pitch levels, a top line and a baseline, suffice as reference lines for defining virtually all perceptually relevant rises and falls. So so top line and a baseline. So if you just take into account that this is the baseline, a little above 100 hertz, and that the top line moves all the way from 200, between 200 to 300 hertz, and you have your most significant pitch events there, the prominent part. So for British English, a distance of 12 semitones between baseline and top line gives satisfactory results. For Dutch, 6 semitones, and for German, 7.5 semitones. A very drastic reduction in the variability of pitch fluctuations. So now we can see that that we need to understand that the pitch fluctuations that are happening, which are controlled by the speakers, are controlled by because it's driven by certain aspects of prosody. Here we can see prominence, and those are the things which have the important things in the prosody, in the utterance, which have to be captured by any prosodic model. So other models like the Fujisaki model with curvilinear approximations such as cosine functions will also obtain similar outcomes, as in get the most important pitch movements, and no fundamental reason to use straight line segments. It's most important to capture the parts which are most prominent. So, and then however, in the T-Hart model we have neatly segmented discrete units. So in understanding perception of pitch, close study of stylization was the first step in the description of intonation from the perceptual point of view. So perceptual equivalence, the same speech melody can be recognized in two realizations despite easily noticeable differences. So, so the same speech melody. So melody is something that is talked about in this type of an analysis, which talks about the continuous changes, or we will talk about the categorical aspects of speech prosody in the phonological models. But here we can see that the pitch changes have been captured. The perceptual relevance and the perceptually important parts of the pitch change has been captured in a closed copy stylization, and it was the first step in understanding the intonation. So gives us such a model gives us an inventory of standard pitch movements. Combinations of these generate perceptually equivalent pitch contours. So it can give us standard pitch movements, that these are the pitch movements we have to look that we have to find in an utterance, and these are the ones that can be predicted to be found in an utterance, and also that the combinations will give you the contours. So many approaches to computational modeling or stylization of fundamental frequency contours have been proposed. So the Fujisaki model of phrase and accent components of intonation, the linear component model of T-Hart et al. 1990, and the tilt model of Taylor. So all these are models of computational modeling or stylization of F0. So the computational models of intonation and tone were developed by Berembert and Gibbon, and Hurst's model, Merton's prosogram model, and the collection by Sagisaka et al. So all these are computational models of tone and intonation which have been developed. And this is the grid lines, is showing the same sentence that you saw before, showing the baseline, midline, and the top line that we talked about. So we can see the baseline, we can see the slide movement for the midline, and then we can see the top line. So now we again talk about something which we have talked about quite a lot in this course. We had an entire lecture on stress. So stress is very important when talking about prosody and the level of various levels of intonation. So stress is cued by duration and or amplitude at the word level. Stress syllables are longer and louder. Stress is cued by fundamental frequency at the phrase level, that is pitch accents. Remember, the pitch accents, they're also at the word level. There are the syllables in various languages. Syllables have stress. There's at a higher level, at the phrase level, you have sentence level stress. Stress words have pitch accents. Intonation is largely a fundamental frequency, but duration and or intensity can also be cues. So other aspects like pre-boundary duration is correlated with prosodic structure. Pre-boundary lengthening increases indicate higher domains in the hierarchy. So there is always boundary lengthening, showing that now when we talk about the phonology and we talk about the levels of organization, we can understand some things about lengthening, pre-boundary lengthening, etc., which happen at higher levels of the hierarchy, where you saw in the beginning, you saw the phonological analysis of prosody. You saw that there could be an utterance level, there could be an intonation phrase level, and there could be other phonological phrase levels. And if you have pre-boundary lengthening, that is you have two phrases, then before that you might have lengthening. Segmental aspects depend on also depend on prosodic position sometimes. So when we talk about segmental aspects of prosody, the one which is important, which comes to mind, is domain initial strengthening. And in higher prosodic consonants, we again find domain initial strengthening. We have that is in the initial parts of an utterance of a phrase. You will find that they are mostly phonological processes like assimilation do not happen, and they are segments are most faithful to their actual underlying forms, and then we have strengthening in those forms as well. And we have acoustic correlates, example, increase closure duration and increase voice onset time in higher prosodic constituents. So these are the phonetic aspects of, of phonological constituents. So we saw that how the perceptual models were developed for understanding intonation, and then we have also phonological models which understand them as abstract units. When we have those even in the construction of those abstract units, we talk about the acoustic, phonetic aspects of prosody. So intonation, we come to the level of the sentence level, that is the utterance. When you look at it, we look at it from various angles. We look at it from the phonetic angle and also from the phonological angle. When you look at it, we try to understand the utterance from, we try to understand the changes. Even when we are discussing the abstract parts, we try to understand how the phonetics contribute to understanding those units from the acoustic, how the acoustics contribute to our understanding of the abstract units. So intonation is the control modulation of voice pitch across a phrase or phrases. So this is what initially, remember when we talked about intonation, initially we talked about how in certain interpretations we have the change in melody. That is the change, the continuous change in relative melody was the way that it was defined. Now we understood after looking at those models that actually there's a lot of control there. When the changes happen, the changes do not happen in random way. We saw how Alan's in Cambridge studying botany, so we saw how speakers control the parts which will receive prominence. So that is why we call intonation a control modulation of pitch across phrase or phrases. So all languages seem to use at least some intonation to mark prosodic differences in meaning. Example, questions and statements, we will see those in another lecture when we're talking about what's the difference between a question and a statement, or non-linguistic information like attitude or emotion. So, and these are three diagrams showing you just what we talked about just now, that it is control modulation of pitch. So why do we know that it's control modulation of pitch? You saw how parts were emphasized when you saw the English sentence where where we saw that Alan's in Cambridge, and we saw where the first part of Cambridge was emphasized. And then apart from that, what we just now said, that it is controlled modulation of pitch. So what do we mean by that? So we see these three English sentences. The control modulation is seen because this is a declarative sentence, this is the pitch contour of an interrogative sentence, and this is an incredulity, like, and can you believe it? So when you have a sentence like that, you have rise and a fall and a rise, and when you're asking a question, then you have an interrogative sentence and you have a rising. So intonation, so to mean that you are asking a question, whereas if it's a falling, then it is just a declarative sentence. So this is the control modulation of pitch, and we will look at more into this in the following lecture. And however, one should remember that such forms of descriptions don't give us enough means to describe more complex patterns. They don't allow us to see the layers of patterns. So while this is extremely true, this is the control modulation of pitch, this does not now let us see more into this utterance. So we want to know where exactly the fall happens. We want to know where exactly the rising happens. We want to know which part of are there parts, what are these rise and falls, where in the utterance, what in the utterance ties them to particular locations, or can it be just anywhere in the sentence? You can have a rise or a fall, or to mean interrogative, to mean falling, to mean to mean incredulity. Are these tied to some locations in the sentence? So all those complexities are not visible here, even though you can see the control modulation. So when we talk about intonation in the other lectures, you will see that intonational contours can be described as a string of categorically distinct tonal elements. And the autosegmental metrical model that we will discuss in the other lecture shows that it's a contour, it's a grammatically governed concatenation of pitch targets, and English accent intonation is determined by three parameters: pitch, accent types, pitch, accent and phrasing, and these parameters are independent of one another. So in this lecture, we have now seen how phonetics plays a role, acoustics plays a role, how our perception has been modeled in closed copy stylization, where we understood that some parts of an utterance are the parts where you have the actual pitch movement, and we saw that with the English sentence, we saw that with the Dutch sentences, and when it is important for any analysis to capture those vital points in the utterance. But we also have models, and apart from that we have computational models which can do those predictions, and apart from that we have phonological models which studies the complexity of an utterance in great detail, as to why you have domain initial strengthening, why you have final lengthening, why certain parts why you have a pause in certain parts, why do segments change at the phrase level, and what exactly is governing those changes, and why do we have utterance breaks, why do we have utterances into different chunks in a sentence, that we do not, when you're saying a sentence, we are actually taking breaks in the parts, and why are we making those breaks? So those details are studied when in the phonological models such as autosegmental metrical model, etc., and also the tones, the tones which could be called a pitch accent, and why are they why do they occur at particular locations, what are the types, what are the breaks. So these are studied in great detail in the phonological models of intonation, and we will start looking at those in the next lecture. So thank you for your attention, and we will continue with tone and intonation in the next lecture, where we'll also talk about how a tone language is different from an intonation language. Thank you for your attention.